I realized in my previous example we did the first derivative, but we forgot to talk about the second derivative. So here's another example with a parametric curve where we're going to do the first derivative and the second derivative. The first derivative is up there, like we had derived in the previous video. It's just going to be the derivative of y with respect to t divided by dx dt. Now for the second derivative, it's the same idea. We're just going to take the d dx, so the dy dx, meaning that you're going to put the whole dy dx in at the top. All right? So we don't have to rederive it. We're just using the formula that we used before again. The curve I'm going to talk about here is this curve with those equations up there. So this is kind of a standard curve. What I did want to point out is as you graph this, you'll see increasing t, the path goes like this. It goes down here, loop around, and go back. So I did say, I forget, like t from minus 10 to 10 or something. It turns out this is t negative is down to here. The t equals 0 is here, right, which makes sense. X equals 0, y equals negative 1. Just plug it in. And then for positive t, it's going to come up and ricochet out that way. So as t goes out to infinity, it's going out that way. Okay, so that's what this curve does. The questions we wanted to answer, okay, where does it have a horizontal tangent and vertical tangent, and also where is the curve concave up and concave down? Of course, with the picture, you can kind of imagine the answers. It looks pretty straight here, but that's because I drew it bad. It actually does curve up a little bit like that. So if you put it in Desmos, you'll see. So we have a region where it's concave up and some regions where it's concave down, as well as from the graph, you can see a horizontal tangent and two vertical tangents. So let's go through and see how we can do that, figure that out with calculus rather than just, okay, here's a picture that the computer drew for me, so it must be the case. Right, but these are fairly straightforward because they're just polynomials. So dy dx is going to be dy dt over dx dt. Okay? So we can pretty clearly see that our horizontal tangent is going to be where that top is 0, so 2t equals 0, so t equals 0, which we just said that xy coordinates were 0 and negative 1. Okay? Now for my vertical tangent, I'm going to have my bottom be 0, and again, where the bottom is 0, my top is not going to be 0. So that will correspond to t equals plus or minus 2. Okay, so I have to find what x values that corresponds to, right? So for t equals 2, x is what? 8 minus 24, right? So this is negative 16. And y is 3. Okay? So that would be, you can't really see it, negative 16, 3. That's this one. So this one, 0, negative 1 corresponds to t equals 0. And for some reason I did t equals 2 first, but that's okay. That corresponds to this point, which is negative 16, 3. And then if I do my other t equals minus 2, then what do I get? I have, so positive 16 and y equals 3. So that's going to correspond to this point. T equals negative 2 corresponds to this point. All right. So it's interesting just sort of to look at that, and you can tell, I said it already, but you can see that that's what's happening as t. These are the negative values of t. They're going through here. T equals 0 is here, and these are the positive values. So if I only graphed on my graph t goes from 0 to 5 or 10, I'd only get this piece, I wouldn't get the other piece. Okay. So there are our horizontal and vertical tangents. The second thing I wanted to talk about, though, was the concavity. Okay, so let's look at we need to look at the sign of the second derivative, and where is the second derivative positive and negative. Okay, so first thing up here, I have to take time derivative of this guy. Okay, so it's a little bit of a pain because I have to use the quotient rule, but I guess we can handle that, right? So this one times the derivative of that minus this one times the derivative of that. Okay, so this is 3t squared minus 12 quantity squared. This is going to be 6t squared minus 24 minus 12t squared. So I get minus 6t squared minus 24 over this guy squared. Which is fine and good, but I'm not done, right? That's just the top part. I have to divide it by dx dt. So you'll get the wrong answer if you think you're done here. It's not just the time derivative, you have to divide also by dx dt. So I'm going to get rid of this because I don't need this. I'm going to write it up here. D squared y dx squared is this guy, which is the time derivative of dy dx, divided by dx dt, which is going to be another 312t squared minus 2. Okay? Then get rid of this. That. Clean this up. These two combine. What I need to know is where is this positive and where is this negative? Because if I want to know about the concavity of the function, I need to know about the sign of the second derivative. Okay, so it's a little bit of a pain, right? But it's the usual thing. The top, I can clean this up a minute. 4, but it's a plus. And then I have this thing. Almost done. So here, my top is always positive, right? Because it's t squared plus 4. Well, my top, this is always plus and my top is always negative because of that minus. But this bottom part is going to change, right? So I've got 3t squared minus 4, that's equal to 0. That t equals plus or minus 2. So I do a sign chart. I don't have any points on my sign chart from the top because it's always the same. And I can just put in some values. If I stick in t equals 0, right, I'm going to get something positive in there. If I stick in t equals 5, right, I'm going to get something, this top is always negative, but then this bottom is going to be positive, so it's going to be negative here. And similarly, if I stick in equals minus 5, we get something negative there. So that's going to tell me that my function is concave up from t goes to negative 2 to 2, and concave down for t greater than 2, well, it should probably be less than negative, yep, then t less than negative 2. All right? So remember, it's t though. All right? And in fact, if they wanted the points, we have the points because we found them from the previous part. But from t less than negative 2 is this branch, and t greater than 2 is that branch. So both of those are concave down. Whereas concave up on this part right through here is where you're going to get a facing up.